Hello, welcome, JavaScript Meetup. We're here again, and this evening we're going to have Mr. Mike Labriola, one of our, in fact, the one of the sponsors. What a glorious gentleman he is, and we would love to drink his beer and eat his pizza soon.
Yes,
is here to talk to us. So there you go.
All right. So we're like Joe's title for this, but we're going to talk about reducers in React. But to do that, we're going to talk about reducers, and to do that, we're going to talk about functions, and to do that, we're going to get kind of functional on stuff, because that's what I do, and you're all here to listen to me, so why shouldn't I do what I like? But yeah, we're going to get into some functional stuff. We're going to get into the relationship between those things and how pieces come together, and the whole goal of this. It's not necessarily that you should do this everywhere, but it's a way of thinking about this that's different. There's a lot of frameworks that use reducers and reducer patterns, and they have their own opinions on things, and I don't like any of them. But I mean, there's good reasons and there's good patterns behind it. And to be honest, everything I'm going to show you works situationally, and everything they're doing works in a different situation. That's how code works, right? We're all trying to optimize for something, whether it be reusability, performance, understandability, localizing code to a given area. We're trying to figure out something. This is my take on it. I like playing with functions. I think that functional code can be really elegant when we do it right. And so a little bit tonight we'll be just talking a little bit about really understanding reducers. And then if we really understand reducers, how do we scale that up to what you could call in React kind of something like a functional reactive reducer in some ways. And then once that is actually there, how can we abuse the hell out of it to do cool things that it didn't intend to do? Or maybe they did. I don't know. I guess I can't know for sure. But how can we do that to do some really interesting things and build on it? So we'll take a little walk through it. To be honest, however far we get, we get. Meaning that I think we should, if there's questions, stop me. Let's talk about them, because to be honest, I think that I like that, number one, in presentations. But number two, I'm going to probably say some things that are sometimes obvious and maybe to me or to someone else, and they may not be to everybody. So let's talk about them. And then let's just try to get on the same page, because if you come out of this and there's a lot of stuff that makes sense about reducers, then it was a successful presentation. So that's my goal. So that's where we're going to go, and we will see what happens. Also, I'm going to do my best to share my screen in such a way that it is both real estate capable, so I can see things, and also in such a way that everyone else can see them. But I'll need your feedback if things are too small for you to see at different points in time, and we'll work with it. So is that reasonable for everybody as a starting point?
Sure.
Looks good.
All right, good. Okay. So we're going to start with this. Oh, and by the way, I may not actually be able to see you because I'm using all my real estate for this so I can present better. So if I'm talking and you really want to interrupt me, just scream at me. It'll be easier. And if you just want to scream at me, that's okay too.
Mike!
All right. So let's start with reduction. Okay. And there's a relationship in all of the functional stuff to mathematics. So we're going to start there. And it's one of the places I always start with it. But if we have an array of things, okay, so let's just say that we have an array of values and we have 1, 2, 3, 4, 5. We know that if I asked you to add up this list, you could do so. But we don't think about it that way a lot in our mind, or how we actually go about doing it. For the most part, if I asked you to add up this list, the first thing you would do is you'd add up 1 and 2. So you'd say 1 plus 2. And then you would probably add 3 to it. And then you would probably go on and add 4 to it. And then you would probably go on and add 5 to it in your head. Now, you may not even realize that's what you do at some point, and maybe you'd go in the other order. Maybe you'd say, oh, well, it's a lot easier for me to say 5 and 4 and 1, and then I'll add the 2 and 3. But the point is that you're probably grouping things in such a way. And this becomes a fundamental part of what we're going to talk about in terms of reduction, because one of the fundamental things we care about in everything we're going to do tonight is the fact that we could say 1 plus 2 and then add 3, 4, and 5. Or if we just happen to know that was 3, we could put 3 there to begin with, and then the rest of this should all make sense. Or we could say 6 and the rest of this should all make sense. So this is an important part of what we're going to do, which is that at any given point in time, we can understand that our progress through iterating through any sort of operation could be replaced by the value at that moment. So whether I sum up something or I sum up part of it, give you that subtotal and ask you to sum up the rest, it's going to turn out the same in the end. And that's an important thing for you to buy. So in an array and in JavaScript, although there are many versions of this in many different ways, we do on the prototype for array have a function called reduce. And reduce is kind of cool because it does exactly this. As a starting point, we can have something like, let's say, a total, and then we can have v, which in our case will be a value. And so as a really simple version of this, we can say result, or for instance, total is equal to the subtotal. And how do we figure that out? Well, at each step, what we're going to do is we're going to say add the subtotal plus the value. And in these things, it's very common with a reduce function to be able to start with an initial value. There's reasons we may want to do that and may not. And in some cases, it won't matter. In this case, though, what's this going to say? Well, we leave that off for a minute. It's going to say that the first thing we're going to do is we're going to add 1 and 2. And then the next thing we're going to do is take the result of 1 and 2, which is going to be our subtotal, and we'll add 3 and 3. And then our subtotal would be 6, and then we'll add 6 and 4. All right. So if we start with this, it's really the same thing, but we're going to say the first thing is going to add 0 plus 1, which again is going to look a lot like the same thing, where then we will add 1 plus 2. So looking through this really quickly, I want to go through this because if we don't understand this pattern, there's nothing else we're going to get tonight. So let's start here. If we go through and we run this operation, what we have here is that as we start taking this values array, which is going to be 1, 2, 3, 4, we're going to see that at each time, this function, which happens to be the signature of reduce, is always going to take something that we call the accumulator, which can be named anything we want. In this case, I've called it subtotal. And so it's going to be our running total, if you will, and it's going to be a value. So at the beginning, it's going to be 0, because we said that we're going to start with 0, and we have a 1. And then when we run it again, we're going to say that we have a subtotal so far of 1, and we're going to add 2 to it, which means our next subtotal should be 3, and we're going to add 3 to it, and our next subtotal should be 6, and we're going to add 4 to it, and then our next subtotal should be 10, and we're going to add 5 to it. And then when we're all done, if we did it right, we should get a return value of 15. All right, so that's fine. And people can find a lot of examples of this, but we want to take it a little bit further. If we understand that the signature here of this is basically that we can take a subtotal plus a value, then we can make a function. Let's just, as a starting point, call our function add. Okay, and our add is going to take a value 0, and it's going to take a, so we'll do a value 0, and we'll do a value 1, and it's going to add value 0 plus value 1. So now we could substitute our add function in here for what we had, because it's really the same thing. So now what we're saying is that we're going to add that. In fact, let's just call it sum, because in math, that's what we actually do call this. When we take an initial value and we add something to it, it's a sum function. So if we run this the same as we did before, we're going to go ahead and we'll get through and we'll actually have a total. And our total, when we're all said and done here, is going to be, yeah, it was dumb of me, but I'll worry about that later. Our total is going to be the same. Okay, so the gist of this here is that the reduce, if we look at the signature of reduce, if we were just to look at the code highlighting here, we're going to see that it takes a function, which takes a previous value, a current value, and it could take some other things like our index, the whole array, some other things we want to work on, but it's going to return something. It doesn't always have to return a number. It could return anything we wanted it to. But the interesting thing is that it's usually going to be in some way related to the things we put in. So if we agree that we can make a function that does this, well, then we can start playing with stuff. And that's where it gets kind of fun. Now, the next part of this gets to where we get into higher order functions, which are going to be a big part of what we're trying to do here. So this right now is a sum function which takes a value 0 and a value 1, which means if I wanted to call it, I would say sum of 10 and 5, and I would expect 15. Okay, and that is one way to do this. But I could also separate these arguments if I wanted to. I could say, you know what? I want to have a function that takes a value 0, and then I want it to return a function which takes a value 1, and then I want it to add them together. So what this would look like instead is that to get 15, I would say, this may be the first way, is I'd say I have a function which is equal to sum of 10, which isn't going to give me a result right now that I can add. It's just going to give me another function. And what type of function is that going to give me? It's going to be one that's waiting for value 1. So that means that I would have to say function of 5, and now I get 15. So to make sure we're clear on this, 10 would be value 0. And then when I call the function again with 5, we'd have value 1. Now I did this as 2 steps, but I could just as well say function of 10 and 5, and we'd be able to add everything together that we wanted to. Now, why I'm doing this craziness, and we'll get to maybe occurring in a little bit of depending on how we talk about things. What we're doing is we're separating the arguments here. So instead of having a function that takes multiple arguments, which is what we started with, we turned it into a series of functions, each of which takes an argument. Okay. Now, the reason I wanted to do that as a starting point is it begins to show where reduce gets really powerful, because adding up a sum is one thing. But what if instead of values here, I could have functions? What if I had something that said like value functions? This part might get a little crazy, but stick with me for a moment. What if we wanted to say that we had value functions, and the first one was going to be responsible for adding 10, and the next one was going to be responsible, I'm going to name this back add for a second because it'll make more sense. This one's going to add 10, and let's say the next one's going to add 15, and then the next one's going to add 20. All right, so now we can go back, and this is still an array. As I mentioned that on any array at all, we can call reduce. So now we're not really going to have the idea of a simple value and a sum or something like that. We're going to have this thing again, which could take our previous value, and it could take our next value. And when we were doing numbers, these both happen to be numbers. Okay, so this was always the last total, and this was the next. We don't have to. So we could say something like this is our running total, for example. We'll call it running total. And this one is going to be a function. Okay. And to that end, what we're going to do for a moment is we're going to say, you know what we're going to do is we're always going to take this function we got, and we're going to apply it to our running total. Now, when we run this, what's going to happen is we're going to start with 0, and we're going to add 10 and get 10. We're going to add 15, we're going to get 25, hopefully, if I did that right. Then we'll get 45. But if we go in here, we'll see what's kind of happening a little bit, which is, and I'm going to break this one, by the way, this is perfectly fine to write this, but sometimes it's easier to see these across multiple lines. So when I break this apart, it's simply so that we're going to have a little easier time debugging this in a moment, okay? So I'm going to do this. Same function, nothing changed functionally about what I did, just breaking it across a couple lines. So I'm going to go ahead and run this. And we're going to see that as we get in here to begin with, our running total is going to start with 0. And we have a function, we can see that. Well, the first function we have is this one that adds 10. So if we step into this, we're going to come here and we know that our running total was 0, okay? Or we're going to running total was 0, and we want to add 10 to it. And so we're going to return a 10, which means the next time we go through this loop, our running total is 10. And now we have a function when we step into it that's going to add 15 to it, and we get 25. And then we're going to have something that eventually returns 45. So what we just did here is we reduced across a series of functions where the functions were our values. And at each iteration, we applied the function to get our next result. Okay. So what that meant is that you can think about that our running total was always the application of our previous running total plus this next function. And this is a concept that you'll see a lot in some of these things in reducers, which is to say that state 0, meaning the state that the system is in right now. When I say state, could be like a redux state, it could literally be a number, it could just be where we are in the system. Could always is always part of something. So I can say that the state 1 or the state at time n, so sometime in the future, okay, is always equal to some function, something I do from state 0. So what does that mean? If I am looking at a view and I don't have anything selected, then my function could be selecting something. So what does the new view look like? Well, the new view looks like where I started with some function of, wow, that was not what I intended to do. The new view looks like some function or the initial state with some function applied, and that gets us to the new state. And this is really proximate to what React is trying to do in general, which is saying that the next version of what we see was our last state with some function applied to it. And there's a couple borders there because of the way React works and some other things. But this is how a reducer works. When we say use reducer in React, okay, we're expected to provide it a couple of things that might look really familiar here. The first thing we're expected to provide it is some function. And what's that function supposed to do? It's supposed to take something like our running total and a next value and it's we'll call it value for right now, and it's supposed to return the next value. Okay, that is what a reducer function in React looks like, which you might notice is very much like what we were doing up here. It takes an existing one, a next one, and it's expected to return the next. And then the next thing it takes is an initial value. So what do we have here? We have a 0. That would have been our initial value. Now the React one takes one other one that I like that we're going to probably exploit, which is an initialization function. And really this just says that, hey, sometimes it's actually kind of hard to figure out what our initial value is going to be. So instead of having to do it in line, I'm going to let you pass in a function if it's really complex, and then you can go do it over there, and then that'll be my initial value. But the point is that useReducer is fundamentally related to this just concept of doing reduce on an array. The thing that we're trying to reduce is in here, we have a series of values. In here, we really have a series of actions, a series of dispatches, events. You can think about them a bunch of different ways, but a series of things that are going to happen over time. And each one of those things that we do is going to take the previous state and change it into some type of new state that we can then use to update the UI. It's the fundamental of what React's always been about, but with useReducer, they tried to make it a little clearer. Now, when you get to frameworks like Redux, they're doing the same thing. There's some opinions on what to do and where to do it, but the gist is that we're always doing the same sort of thing. Now, by default, the React version of this says, well, instead of a running total, what I should get is some type of running total, or we'll just call it for now our state. And then when we get a value here in React land, a lot of times this is an action, which is some sort of piece. But if you look at it for a minute, up here, we said we took a running total and a function, and then our result was always our function applied to a running total. So we need a way to convert this action into something functional. And in most React parlance, what you actually see is somebody do either an if or a switch statement, which says if my action dot foo is equal to bar, then run return some function of, wow, that was nice, some function of state. And if my action dot bar equals foo, et cetera, et cetera. So we get these either nested switch statements, or we get conditionals, or somebody puts them on an object prototype and destructures them or dereferences them. It doesn't matter through indirection. The idea is that in some way or another, we ultimately have to return or turn this action into something that can change, or not really change, that's mutation, but can provide a new value based on the old one. So it's all about taking this thing and turning it into something that looks like this thing. And that's actually the premise of what I'm talking about. Is I think it's kind of fun that we spend a lot of time turning this thing into something that looks like this, when there's nothing in this contract that doesn't let us pass that thing in to begin with. So we're going to spend some time on that together. But there's some prerequisites, as there always are. So this is a presentation I did for Progress, who does the Kendo UI components at one point, and it was kind of fun back then. I wouldn't have come up with it on my own. They wanted me to do something casino themed, and I thought it worked out pretty well. But we're just going to take a little walk through just the basic code that gets us started, and then we're going to talk about how we can work with it. So just this is that it's going to be a blackjack game. And for those of you who don't know, because last time I did this with Tyler McGinnis, it turns out he didn't know what blackjack was. So I'm going to not assume that this time. It is a game where we are playing the Price is Right with cards. We want to get as close to 21 without going over. And whoever gets the closer, us or the dealer, wins. All right. So to that end, we have a couple of reference functions, because I wasn't going to code this all together. We have a function that we're going to call toCard. And it's going to take a name, which is really about what the name of the card is. Is it a 1, 2, 3, 4, what suit it's a part of? And it's going to have a value function. And there's a reason. In blackjack, aces can actually have two possible scores. They could have a 1 or 11. So it's not as simple as really just simple, straightforward math, because we have a possibility. We almost have a tree that at any given point, if we have 3 aces, for instance, we can actually have 3 or several very different values. It's not just 3 that could be represented. So this toDeck function basically takes the pip cards, and pip cards are which I didn't know before I started this, are basically all the cards that are numeric. And it's going to mix those together with the suits, which are our clubs and diamonds and hearts and spades. And it's going to get these court cards. So our deck is basically defined as, I want to take all the pip cards and I want to make a card for every one of the possible scores that goes along with that and stick it in the deck. And I want to take our court cards, which are our Jack, King, Queen, and King, which are all worth 10. and I'm going to stick those in the deck. And then I'm going to take an ace card for every one of the suits, and I'm going to say that it can be worth 1 or 11, and I'm going to stick that in the deck. So our deck is really a combination of, at the end of the day, a bunch of functions. Okay? It's because I like functions. All right. So one last thing we're going to do here is that we are going to have something that we'll use in the background called toInitialState. Now here's the gist. When you go to Vegas and you decide to play blackjack, they don't just pull out one deck of cards, because one deck of cards would be a lot easier for somebody who understood what was going on to figure out, hey, I've already seen that card, I'm never going to see it again. So there's always a number of decks which are shuffled together. So all this thing really does is say, how many decks do I want to start with? And I'm going to go ahead and make decks out of each one of them, shuffle them together, and that will be what I start with. All right, so my initial state is just that. Okay, last thing I did here was write one more function that I'm going to call total of. And this is just because of the fact that since there are aces that could be 1 or 11, and I have to do the math to add them up, what this really does is it'll take my hand at any given moment, and it's going to take, this should look real familiar from the stuff we just did, the totals and the value, and it's going to figure out what the best possible outcome is. Meaning that it's going to take the possible values we could have, and if they're over 21, well, it's going to exclude that possibility because that would mean you lost. But if it's not over 21, it's going to get the highest possible value it could for you out of the cards you have in your hand. All right, that's all the code we're going to really start with on this side. On the React side for a moment, we're going to start with just a little bit more too. And it's really the view you see on the left. It's not a lot to it right now, but there's going to be these controls, which are basically, I have an on-click for deal, I have an on-click for hit, I have an on-click for stand. And then there's just some things that disable a button if I'm playing or not. Okay. For our hand, once we have one, it's going to map it out and it's going to show every one of the cards. And this is just a rule of blackjack. The dealer's first card is shown face down. So it's going to do that. All right. So in this, we're going to start with a React reducer. And this should be kind of like what I was just talking about. Remember, we have running total would have been what we did before. But instead of running total, since it's not going to just be a number, we're going to call it state. And we're going to take a state and we're going to take a function. And as soon as we do that, we're going to say our next state is going to be that function applied to the state. And for our initial state, we're going to go back to that function I already pointed out to you, which is going to take some number of decks, in this case 4. It's going to shuffle them all together for us. And then we are going to have our starting spot. And in that state, we're expecting to have a player hand, a dealer hand, and a status. And that's just going to be what's shown on the screen. So that's all fine. We need to get that kind of going. But in order to do anything useful with this, we probably need to start getting some cards on the screen as a starting point. So what we're going to do is we're going to start writing some of the functions and we're going to do them all as reducers, probably maybe ad nauseum, meaning we're probably going to go a little further than would you necessarily need to do in these sorts of situations. But I think it could be kind of fun to do that and to see the possibilities of how one could go about doing this and how to maybe, build this thing in a totally functional kind of way. And there's even further we could go, but we're going to start here. All right. So what we're going to do is we're going to start with the idea of deal, because we aren't going to be able to do anything until we get a deck up here. And so to deal, we're going to need to dispatch something. Okay. And so the way it works with useReducer is that useReducer gives you back what the current state is. In other words, what the last result of this was. Okay. And that's when we saw it. So this you can think of again as our running total, but for the outside world. And it gives a dispatch. And a dispatch is this seemingly important thing that people attach way too much importance to. What it really means is a way to provide that value. Okay. We could call this that which was dispatched. Okay. And all it is whatever I put in here is whatever is going to show up here. So to that end, we want to get something in here because nothing's going to happen until we can start calling this function. So we're going to come down to this dealer on click, and we know we're going to have to dispatch something. Now, here is the place where people would start dispatching all kinds of fun and cool and interesting things. And those things that they dispatch could be as simple as an object with some properties. So if you're a Redux user, you're used to seeing that I'm going to have a type, and my type is going to be foo, and then I'm going to have a value, and that would be the essence of what Redux does. Is it standardizes on that shape, is saying, hey, all of our things that we're going to call an action should look like this, and it gives us a nice, easy way to figure out what we should do with that action. Has some advantages, has some disadvantages. So there's other ways to look at this world. Remember, anything we pass in here can be sent somewhere else. So what if instead we said that this was going to be something like our deal reducer function? And what does that mean? Well, that means a function I'm about to write. Okay, so we'll go over here for a second, and we're going to say that's a function. All right, it's a started. Now, what should that signature be? Well, we know that anything that I dispatch, this guy is going to end up right here. So that tells us already it's the type of thing that needs to take an S0 or a state 0. We can call it whatever we want to, but we'll call it S0, which, if I wasn't clear before, just stands for state 0. Okay. So I already said that when we make our initial state here, we're going to have a deck. So that's the only thing we can really rely on. So we know that one of the things that's going to be in our state as a starting point is that we will have a deck. And if we went and dove through all that code that we did, you'll see that it all says array from. So we know it's going to be an array. So we're going to start there. So we know that. Now our job is to start making the player's hand and the dealer's hand and our current status. So we're going to do that. All right. So as a starting point, what we're going to do here is we're going to deal. Now, when we deal, we pass the first card to somebody, to the player, and then the next card goes to the dealer, and then the next card goes to the player, and the next card goes to the dealer. Unfortunately, JavaScript destructuring gives us a really cool way to do that. We can say card 1, card 2, card 3, card 4, and let's start there, okay? So we're going to pull those out of the deck. And so what we're going to return now is our next state. So remember, our job of our function is to take state 0, which is this guy, and return state 1. So what are we going to do here? We're going to say, well, all right, we don't know what else is in here, and we don't care about, so we're going to return everything that's already in state 0 because we don't want to be bothered. But then we're going to say that we want to make the player's hand. And what's the player hand going to be? Well, it's going to be card 1 because I deal with the player, and then I deal with the dealer, and card 3. And what's going to be the dealer's hand? Well, the dealer's hand is going to be the opposite, which is that the dealer's hand will be card 2 and card 4. Now that would be fine, but then we still have to have the rest of our deck to deal with. So one of the cool things in JavaScript that we can do is a spread operator. So we can say, you know what, let me go ahead and take the remainder of the deck here, which means that our deck now, after we've drawn off 4 cards, will be whatever's left in the deck. Now, just for a good matter, we're going to start with a status. And the status that we're going to use right now are just a couple of constants I defined. So we'll call this one playing. All right. So when we do this and build it, if I typed even half of those things right, what we'll have is that we'll have the ability to say deal. And when we do, what happened? Well, we dispatched a function. So we just pushed a function reference into this dispatch operator. No switch statements, no case statements, no if statements, no indirection through objects. We dispatched a function. That function is the type of thing that took a state 0 and it took the deck out of it and it took some cards out of it and it made a player hand and a dealer hand. Now, nothing else does anything right now because I haven't written anything else. What we did as a starting point is that we made deal go ahead and do some work by simply dispatching a function. And this is the part that gets tricky for folks, is that dispatch in the React world doesn't say what type of thing it takes. It doesn't care what type of thing it takes. So all of the places that you might see online or get information about what it takes are all convention. And convention's the fun thing to break. So in this case, just dispatching a function. But I'd actually argue that it's a little bit more how you would traditionally see a reducer in functional programming. It just so happens that sometimes it's a little harder to understand, so people shy away from it. I personally like it. So that's how it goes. And since I'm in charge of this particular presentation, we get to do this. All right, so let's make some other buttons work. So we've got hit and stand. And hit is the type of thing of saying that we want another card. Okay, so we don't feel like we've done well enough here, so we would like another card. So how are we going to do that? Well, let's go ahead and actually write something like a hit reducer. So I'm going to keep calling them reducer functions just to hammer home what we're doing. It doesn't really matter what I call them, but we'll come down here and we're going to write a hit reducer function. Oh, same deal. What's hit reducer going to be? Well, hit reducer is going to be the type of thing which takes a state 0. And if I wanted to be extra safe here, I would default these, meaning I would say like, oh, if there's nothing there for some reason, let's make sure we have some type of object so we don't cause ourselves a bunch of crashes. Okay, but we have a hit function. It's a hit reducer. Cool. What does it mean to hit? Well, first of all, just a rough guess, we're probably going to need the deck. Okay. And I would guess in this idea, since the idea behind hit would be to take something off the deck and put it in the player's hand, I think it's a reasonable guess to say we're probably going to need the player's hand as well. All right, so those are going to come from S0. Now, what's our job? Well, our job at the end of the day is going to be return whatever was in state 0 already, and then we want to make a new player hand, okay? So whatever that's going to be, and we want to make a new deck. So how do we do that? Well, I think we could start with the deck, which is that we're going to get a card, and then we're going to have the remainder of the deck. So when we're done, what's that new deck going to be? It's going to be just like it was before. It's going to be the remainder, whatever is left after we take off that one card. And what's the player's hand going to be? Well, it's going to be a little different, but the new player hand might be equal to that card that we just pulled off, but it's probably going to be after the existing player's hand. So the new player hand will be whatever the player had before plus the new card. So if we go ahead and throw that in here and return that for player hand and we save it, what we'll have now is the ability to say deal and hit and hit and hit, and we can keep adding cards to the player's hand. Okay, that's pretty cool and that works. Now, it's not obviously doing any scoring yet, and we'll get to that. But there's one other operation we need to be able to do. And that other operation is to say we feel like we did well enough. We're going to pause and we want to see what the dealer can do now. And that one's a little trickier because in blackjack, after the player says they're done, the dealer goes until the dealer either wins, loses, what's going to be, or I guess you can technically push, you can draw, but for the most part, it's going to be till the dealer wins or loses. So the dealer's going to keep going. And this is where this gets really cool, in my opinion, because these sorts of things can do all sorts of cool little things like recursion. So let's talk about this. So right now we're dispatching a dealer function, we're dispatching a hit function. So what do we want to do with our stand here? Well, we're going to dispatch, probably not surprisingly, some type of stand reducer function. What are we going to do with our stand reducer? Well, let's think about it. Our stand reducer is going to be the type of thing that, again, takes a state, and its job is to return a new state. So we already know that we're going to return some type of new state. It's probably going to, again, be whatever composed of whatever our state was before, plus some new things. Well, what kinds of new things? Well, we probably can take a guess that we need the deck again. This time, we probably aren't going to mess with the player hand, but we probably do need to mess with the dealer's hand. And we'll take that out of state 0. Okay, so what do we need to do now? Well, the dealer is going to start drawing cards off. So we can kind of think of the same thing here. What do we need to do? Well, the dealer is going to take a card. There'll be the remainder. That'll be the deck. All right, cool. So the dealer hand then we could think of is that the new dealer hand is going to be very similar at first, right? Which is that it'll be the existing dealer's hand combined with the new card. Okay, so we could do that as a starting point, and that would be a cool thing. So let's get that in here. So we'll say the new dealer hand is here, and we'll say that the new deck is here. All right, so let's just see where we're at here. So we say deal, and we hit, we stand, and the dealer drew a card. And that's cool, but it's not like I'm going to keep clicking this button and asking the dealer to keep doing something. The dealer needs to keep doing something all by itself. And that's okay, because we have a really cool way of doing that, and that's called recursion. Because what do we want to do? We want to keep doing this until such a time that we win or lose. So we're going to use that total of function that I wrote up here, which just as a reminder, that total of function, which is just a reminder, is going to take a hand and it's going to return a total. All right, so let's look at that. We'll come down here and we'll say that our dealer total is going to be the total of the dealer's hand. All right, that's going to give us a number. Now, here's the deal. It's not all that magical. When you're running a casino in Las Vegas, you aren't giving every person on the that's dealing for you the opportunity to decide when they think and how they think they should play this game. It's a big numbers game, right? So at a certain point in time, they have a threshold. They know that if they get to, for instance, 17, even if it looks like they're going to lose, that they're going to stand and they're not going to go any further, because on the whole, the casino is going to make money if that's the strategy that they use. So in all cases, we have something like saying, well, as long as the dealer total is still underneath what we're going to call, I don't know if I exported this, but we'll do it in a second, the stand threshold, 17, okay? So as long as we are under 17, we're going to keep going. So if we're under 17, then we want to draw a card, okay? And we'll keep going. If we're not under 17, then we're just going to say we're all done. So even if we got called again, we're going to return the state. Now that's cool, but that still only gives us one card. But the cool thing is that if you notice, I told you before that when we add stuff, if I asked you to add 1 plus 2 plus 3, that's the same as adding 1 plus 2 and getting 3, and then adding 3. So we know that we can kind of always keep calling things with the result of something else. Well, state 0 produced state 1 when we return this object. And that is the same type of thing we can feed right back in for the next state, which means that up here, we can say, all right, as long as we're under 17, go call the stand reducer function again with our new state, and then call the stand reducer again with our new state. So what would that do for us? Well, apparently that would do a bad thing because we did something wrong, but let's go find out what it was that we did wrong, and we'll go from there. Oh, well, we have to save the file. Okay, so coming back over here now, we say deal, and we say hit, and we say hit, and we say stand, and okay, well, that time was less successful because there was only one thing to do, but let's go ahead and do it again. So this time we say deal, and we'll say stand right away. All right, very unlucky in my first two examples, but that's all right. We'll say stand. We're giving up. It's great. You'll have to believe me that it'll keep going. All right. So the gist of this is that we are going to keep calling this recursively, and we'll see some examples in a minute where we go along. But one of the challenges right now is that we actually don't know in terms of what's happening and how to restart and some other things. So we have to kind of get to that. We have no way to redeal right now. We're still showing hit when this happens. And we have no way to declare who won, even though very clearly, unless that was a big card, the dealer won in this point. So we still have to do a little bit of work here. We still have to figure out some way to go. Yeah.
Question for you. So I'm getting how the reducer function gets called and how it's returning a new state. How does React actually access that newly created state? I missed out on how that happens.
Got it. Let's talk about it. So in this case, we always have in useReducer. useReducer is the type of thing that returns the new subtotal every time that you take the old subtotal, add a new value, okay? So what's going to happen here is that when we dispatch this dealer function, it's going to go in here. It's going to call that function as you saw up here. And if this thing returns a new value, in other words, if it's not identical to what it was before, React is going to re-render this component with that new value in state. Okay, so every time this returns a value that is different than what it returned before, this whole component will re-render itself. Does that make a little sense?
Okay, so it's, because the return on that, on Michael Labriola is returning, I guess, a function, and that gets recalled with the new state? Is that
yep.
What?
So basically,
it ignores that const state where
well,
you're
that const, yeah,
only the first time it uses it.
It's not actually ignoring it, right? So the best way to think about it is that this is inside of this function. So every time this function is recalled, there is a constant for the duration of that function called state. But if this function gets recalled again, then we're making a new constant, which is the state at that moment. And if this function gets recalled a third time, there is a new state, which is the state at that moment. So it is constant in the function. It's just that this whole function gets recalled anytime this thing ends up returning a new value.
Okay.
So it can think about it as almost registering a listener, if that makes sense. And the moment that it sees something changes, it says, oh, I need to re-invoke that to re-render the view.
Gotcha, and that's why you can pull out player hand, dealer hand, and status from state.
Yep.
Every time. It'll always be the fresh version of those.
Yep, it'll always be the latest. And if this happens to return something, by the way, that is not changed, the view just doesn't re-render itself. So it only happens, so if I dispatch something which did nothing, but returned the same value, this would never re-render itself. So it'll only re-render if this state has actually been different than last time.
Great, thanks a lot, Mike.
Yeah, sure. Okay.
Wait.
Yes.
I do have one quick question, because I'm curious if it's just preference. I have a feeling the answer is going to be flexibility.
Yeah.
But if you're going, and this is a pun, I guess, if you're going according to Hoyle rules of React, it's going to be dispatch, and it's gonna have it's gonna have an action, right? Mm-hmm. That action property. And I see you're writing these reducers that kind of have the same setup all three times, and I'm wondering if there is a reason other than general flexibility, maybe testing, that you're not saying, here's one reducer, here's the action, pull out all the state elements I might need, and then based on the action type, do the correct thing. Like I see that it got a little bit different with the stand reducer, but the other two, technically, you could have passed in actions that if the action is hit, deal, sure, stand.
Okay, so tell me what would happen if I took an action that came in and I had a type. My goal would be to take that type and to do what with it?
Produce the new state that you're producing in these three reducers.
Well, it would be to probably find a function that I was going to call to do new state, right? So here's my thought. I'm going to have dispatch where I happen to know the thing I want to do is deal on click. So I'm going to change that to a string so that I can change the string through a switch statement back to a function so that I can invoke the function so that I can get my state. Or since I happen to know the function that I want, I could just eliminate that crap and
so
say,
the answer is
here's
preference.
The function. I think it's even more than preference. It's partially the fact that, and there are good reasons for it, just to be clear, you don't always want to do this. But the gist of this is that all of that Redux and that type actions thing and all the solutions, you'll see people like put properties on an object, which you can look up so that you have easier ways and you don't need switch statements. At the end of the day, they all come down to the fact that I need to map something back to a function. So my only real question is, if we eventually need to map it back to a function, why did we divert from having the function to begin with? Fair question, at least?
Yeah, it's fine. And like I said, I can certainly see.
I know it's fine.
I approve. I'll allow it.
Thanks. Good.
No, I guess also there is testing to be considered, and these are certainly far more testable. So,
and it's not
at least in isolation.
Yeah, it's not necessarily that it's the best way to go for everybody, but I do think there's some really cool advantages to composition. So, let's keep playing with it and see what we get. Fair?
Yep.
All right. So we need to do some more stuff, though, as I was kind of noting, which is that we need to figure out some way to do more than one thing now. Okay. And so the interesting part is that we need to almost take we would need to mix into each one of these sorts of functions something that also figured out how to update this state, okay, or this status. Or we need another function that could do it. But it gets a little tricky here because our signature is such that we're dispatching one thing. It's the only thing that's really here is that this is one thing we're dispatching. But that's okay, because we just learned a moment ago that anytime that we have something like 1 + 2 + 3, we can always add 1, 2, and then add 3 later. And that is the basis for something that we can call a number of different things. But today, for the hell of it, we're going to call it a pipe. Okay? So we're going to make something called a pipe. And a pipe is going to be the type of thing. And if you get lost on this one, I don't blame you. But stick with me. I promise it'll be worth it in the end. All right. It's going to be the type of thing that takes some functions and a state. And it's going to basically do our reducer. So this is going to look just like what we wrote in the beginning, although it's been a little while, so I don't blame anybody for not remembering it. But we're going to take our functions and we're going to reduce them. And then we're going to take something which will be our state. So we'll call this a state. And if we want to, we call it anything we want to. We'll just call it an accumulator for now. Okay. And our function, And what are we going to do? Well, we're going to return our function of an accumulator. And you won't be wrong if you think that this looks a lot like this and that maybe there's an opportunity to do those two things together soon. It probably is, but we'll get to that in a little bit. So, and then what are we going to do? We're going to say we're going to start with a state 0. So our pipe is going to be the type of thing for anybody who's gone with a Unix command line or anything like that in the past. You'll have a pipe operator, and they're really the type of thing that take multiple functions and something you started with, and then it takes the first one and it applies a function to it. And then when it's done with that, it applies a function to the next one, or it applies the next function, the next function, the next function, and you keep piping things through until you get a final result. And this can be kind of interesting because what it really means in some ways is that we can take lots of functions and we can combine them together and make one function out of them. So just for fun and to stick with me for just a little bit longer here, if there's any pitchforks and stuff, I expect somebody to let me know before we get too much further. But what we're going to do here is that we're going to make some status reducers. And these might get a little verbose for right now, but they're more to prove the point than anything else. So let's just say that we will want to handle up front what happens when we hit. Okay, so we're going to say that we're going to make something like a hit status function. Okay, so we're going to call it hit status function. And its job, or we'll call it a reducer function, just to be consistent with what we did. Its job, again, is going to be to take a state 0. Okay, and we're going to return something. And our status function's job in life is to really set just one thing. However we do it, it's going to be to figure out if our status changed. Okay, so these functions are all about really affecting the player hand in the deck. These functions, and this one is going to be about the dealer hand in the deck. This one is going to be just really how do we modify the status based on something. So what we're going to do for right now, and there are places we could optimize this, but I don't want to get too into those weeds at the moment. So we're going to say we're going to pull out the player hand. And what we want to do is we're going to get the player total. And we're going to get that by saying it's going to be the total of the player's hand. All right. And we know we already said up front that this is a game that we want to get up to and as close to 21 as possible, but not to go over. So our new status is going to basically depend on what that player total is. So if that player total is greater than the max sum, and I probably need to export that too, so give me 1 second. Yep, I do. All right, so if that is greater than the max sum, don't keep VS Code, I will going to do something, which is that if I went over the max sum, probably means I busted. Okay, so in that case, I'm going to do something. It'll just be a constant here, and I will say result player bust. Okay, I failed. Otherwise, I'm going to keep playing. So if I come over the max sum, I do that. Otherwise, my status is still going to continue to be playing. Okay, so what's that going to do for us? Well, absolutely nothing right now because we're not calling it. But if we come down here now and we look at this, right now we dispatch a function on the hit reduce, but we need to dispatch one. But our pipe operator is a type of function that allows us to combine functions together, which means now we could actually dispatch sequences from here. So we could say, you know what we want to do? When somebody clicks this, first we want to hit, and then afterwards we want to do our hit status reducer function. And those are the two things we want to do anytime somebody does a dispatch. And so now we have some atoms that we can assemble in different ways, however we want to do these. So we'll deal, we'll hit, and oh, we went over. So now we actually got a message that said the player busted, and we're back to the point where we could start dealing again. Oh, we busted again. So we have a hit status reducer, which is now basically accumulating a status for the hit operations. Again, we could actually combine a lot of this, but I'm going to keep some of it separate right now just while we're talking about it. And so we'll go ahead and we'll actually make sort of a stand status one, which will be what happens when the dealer is going to stand, or when we stand. So let's say that our stand status function I think stand status reducer function is fine. Naming things is hard. Okay, so we'll do an S0 here. And what are we going to do? Well, we're going to go off there. And now to find out what happens when we stand, well, we probably need to know a little bit. Because when we stand, remember, the game is going to end one way or the other. And so we need to know who won. So we're probably going to need to know the dealer's hand. And we're probably going to need to know the player's hand. Okay. And so out of that, what are we going to figure out? Well, we could say, I think, at least, where did I const? Because that's supposed to have an arrow, which makes all the difference in the world. Okay, so we're going to say that, again, we want a dealer total right now, and that's going to be the total of our dealer hand. And Joe appropriately called out that some of this stuff can be brought together. I agree. We're not doing that today. So we're going to do that, and that's going to be the player hand. So that'll be our player total. All right, so now what's the case? Well, if the dealer was done, but their total was over that, well, guess what? They busted. So we'll go ahead and we'll say, sorry, dealer, you lost. And what's that status going to be? That status is going to end up being that we won, right? So the dealer, the status will be the dealer busts. Sorry, result, dealer bust. All right, that's one avenue. We'll keep this pretty loose for right now. If it turns out that the dealer total is equal to the player total, well, that's cool. That means that we actually tied. So what do we do in that case? Well, that's called a push. So we'll do result push. All right. And we're keeping this a little verbose at the moment, but that's cool. In all other cases, what happened? Well, if the dealer didn't bust and we didn't tie, then we can probably make one final determination, which is that if we have a higher total than the dealer total, and we won. And if we have a lower total than the dealer total when everything else is there, the dealer wins. So now, if we go ahead and mix this guy in like we did down here, after we stand, not only do we want to stand, but we want to stand and we want to update that status. We want to do both of those things. Now we can say that we deal, we hit, we stand, and the player won this time. We could deal, stand, dealer busted that time. Dealer won. So now we've got something that's actually fairly functional in terms of being able to reduce, because of the fact that what we're doing is we're prescribing the sorts of actions that we want to do. And you wouldn't be wrong to say like, well, during the dealer one, we could actually, that could be where we decide to change the status to playing. And our initial state really looks a lot like the same sort of thing here, but with an initial value. So that could probably follow the same pattern. So you could start pulling things together, but the gist of this is that as opposed to necessarily taking each one of these things and looking up what we want to do, or coupling these two things together in a final function, we're using functional composition. We're taking a series of tiny little functions. They could even be tinier than they are. We're individually taking them and we're making them part of a larger function. And then we're basically providing that larger function to the current status. We have effectively taken this reducer and made it as dumb as humanly possible. It does nothing but take the function we gave it, which, by the way, means we could add new functions into this thing as often as we want, wherever we want to, however we wanted to do it. And it's just going to blindly take those functions. It's going to apply and it's going to return a new state. We can couple new things together. We can pipe new things. We can do more things together. But we have all these little atomic functions, which one by one can potentially be applied as functions. And at the end of the day, a function has a name. We know it. It's a reference to something, but it's a name. And so, as Joe was pointing out, the common pattern would be that you have a type, and the type goes and looks something up, and then it finds probably a function to call. But I'm kind of saying that the concept of a name is sort of intrinsic to a function to begin with. So as opposed to potentially making a function that we have to map to something to give it a name so that we can look up the name based on a string we give it, we could just tell it what we want. So that's what this comes down to, and one of the ideas. And we can take this a lot further. Well, let me pause there for just a moment and let the hate mail roll in. Joe, you're up first.
I have no hate mail, but eval string did pop into my mind. It's like, just send the action of the function name as a string. Anyways, no, I personally, I think this is great. No. I don't adhere to the reduxiness of useReducer, which to date, I've actually avoided useReducer, but personally, this makes me kind of want to use it.
useReducer is really cool, and reducers can be really cool, but they have been, we'll call them co-opted by a certain and very opinionated set of approaches to doing
Religious, yes.
Yes,
fervor.
indeed. You and I have similar opinions on the cultishness of certain things. However, at the end of the day, a reducer is nothing more than a function. And by the way, this pipe operator is just a functional reduce. And one could call this kind of, and it's a little bit, not exactly, but we'll call this like a functional reactive in some way reduce because it's reacting to something, okay? But at the end of the day, they're the same. This thing is this thing. They're actually the same damn thing. In all cases, this one just happens to know all of the functions it's going to reduce over up front. This one happens to get the functions one at a time as we're clicking buttons. Other than that, this is this. They're the same thing. They work the same. And so the cool thing is that if you understand the functional application of reduce and how we can build on it, then the functional version of useReducer works the same way. And there's so many cool things we can do. So very many cool things we can do.
I think this is pretty cool. I'm not like a React guy at all, but I like the idea that you really have these small standalone functions. You're easily testable. You can, give it an input state and know for sure what the output state is going to be. I guess, would you, in this approach, ever abstract out your piped guys into a named function and just call that, or do you tend not to?
Yeah, you could totally do it. So, in fact, it's probably pretty common for me. So I might have taken this one and just, for instance, said, and that's the cool part about this, right? This is literally hit. There's nothing else to it. And so now I can come down here and dispatch hit if I wanted to, and I'm done.
Right. So you could test the pieces if you wanted to, or the whole thing. And it still all ends up changing one state to another state. I love the composition of that. That's really nice.
And each of these, as you noted, is very easy to test. And like I built them all in this JS file for right now, but normally I would have put them in, even a separate file just to pull from. But that's the cool part, is it's just a bunch of functions that can be exported and tested individually. And these probably in some cases, as I noted up front, like this one is kind of the aberration, right? Because it sets playing. We should really have something that handles that separately, because then we would test a smaller and smaller part of it. And if you, as Joe was indicating, if you squint, there's a lot of relationship and what's going on here that could be pulled out and composed differently. So anyway, there's lots of cool parts about it. And at least for me, I enjoy these sorts of patterns. Functional patterns like this make a lot of sense to me. I find them easy to test. I don't find them hard to understand, but I also know I have a lot of experience with them. So I am very empathetic to the fact that a lot of people look at my code up front and ask what the hell I was thinking. You guys are quiet.
Can I be one of those people that says, "What the hell were you thinking?" So part of the reason I say, "What the hell were you thinking?" I was
talking about you when I said.
Yeah, I knew you were. Being an old school jQuery guy, this isn't very readable to me. In fact, it's insanely unreadable. Even though I watched you do it and I saw you name the variables, I still cannot follow as you're going along and reading the code, right? Because you actually have to understand all of the bits of what are the functions doing at any one particular time to understand what the code is doing that is calling those functions, which means you either understand all of it or none of it.
Now let's take that to jQuery for a moment. How well would you do with jQuery if you didn't know the functions that were in jQuery? You'd be able to have a $sign, but after the $sign was there, what would you have accomplished?
You wrote all the functions in here. This is not me understanding the library that is jQuery.
So what you're saying is I needed to provide documentation. I can do that for you.
Do you think this is more readable than non-functional code?
So to me, it is, but there's another reason behind it. If you notice, every one of these things returns something, which means there's no side effects, okay? This function can change nothing else in the system except what it returned from here, which means I never have a chance of creating a race condition where something modified something else and I don't know why it happened. I never have a chance of creating a side effect where I don't know why something else changed, because everything enters and returns something, and I can see exactly what it is. So functional code is different, but one of the ideas behind immutable functional code is that you're limiting the places that you can possibly create a bug by constraining a certain way of writing it. So ultimately, is it easier or not? Doesn't matter. I mean, I remember I a lot of my original background is literally even below assembly. I wrote compilers, I wrote hex, I wrote C. Certainly you didn't do it this way, although I will admit using function pointers a lot. But the gist of it is that they're different techniques. The advantage here is that you're trading off something that may seem more complicated in one way, but perhaps stops you from shooting yourself in the foot in a different way. That's all. So to me, it's easier, but it doesn't have to be to you. I didn't entitle this conversation "The Things That Mark Should Do Tomorrow."
If it was easy for Mark to understand, Mark would probably think there's a better way of doing it.
So a lot of it is getting used to the syntax, right? I'm used to the syntax now, and the idea of copying things by dotting them, all into the new thing, and the shorthand for function declarations. That takes a little getting used to seeing that syntax. And if you're used to the jQuery, write out the word function or whatever, it can make it a little, takes a while to grok it.
It does indeed. But I promise you, it can be worthwhile.
Yeah, I actually think that this talk should have been called Trojan horse for functional programming, because so I really enjoyed what I'm seeing. I think it's great. Mentally, I'm already thinking could you is your pipe implementation replaceable with the pipe operator? That would even make it even nicer.
Yep.
But you have chosen blackjack with no, there's no. This is a simple application.
Yeah. But I'll tell you, a lot of my applications look like this that aren't so simple.
And are there a ton of little functional abstractions, and do you get tired of naming things properly and just start passing around X's and I's and J's and K's?
We have an application with probably better than 750 to 800,000 lines of code, all of it immutable functional. Still very maintainable.
I'm sure this is just like anything else. Once you get used to the format and the flow, and you identify which pieces are the utility pieces, I think the logic falls out pretty easily.
Yeah, well, as they say, anything's easy once you know it.
Yeah, that's exactly what I meant. I did have one question though. And I think you answered it. So the IDE you're using is called Fuck You VS?
Yes. Screw or screw you VS code, and or you bastard VS code, and or what the hell is wrong with you VS code. However, to be clear, I also love it. It's just we have a love-hate relationship, as all intense, strong relationships really should be. VS Code's awesome in many, many ways. It's a very cool IDE. It has its moments. It tries to be very helpful. And when it succeeds at that, it's amazingly helpful. And when it decides that you meant something that I can't even imagine how they came up with the thing that they just decided to code complete for me, it's less helpful.
Yeah, I refer to those as Microsoft moments. Microsoft thinks it knows how to do everything better than you do.
I mean, statistically speaking, they do.
I would argue with that.
That's the cool thing about statistics.
I tell people I think the window manager on my Chromebook is much better than what comes on Windows 10. But that's just me.
See, it's just all about what you get used to. But no, so, I mean, look, this isn't for everyone. It isn't the approach. But here's the interesting thing. Just for a moment, if you'll indulge me. React works best with sort of something that is the idea that we don't really mutate under the hood, but instead we produce new values because that's how React decides what to re-render. So if we were going to pair this with something that was a mutable approach to changing things, where we have to kind of fight with it, or an immutable approach where we yield something new that automatically React can very easily tell when something's changed, there is sort of a relationship here. And although I will argue and would love to talk about it, that I don't think React is completely functional. And by the way, if you ever look into React's code, I will tell you that under the hood, it's not very functional. But the idea, and it doesn't really matter if there's stuff under the hood, the idea behind React is functional. The idea at its core behind React is that we have a function that, given an object of some shape, is going to produce UI components. It's a projection function. For those of us who are old enough to remember projectors and transparency slides or map projections, right? The idea is that you drew something here and it got bigger over there. That was a projection, okay? And here, in this case, a projection function can be anything. It can be from a domain and a range if you're a math person. It can be a whole bunch of different pieces. But the idea here is that we project from an object to a bunch of UI components. And that's what React is. You write a projection function, it projects your object to UI components and puts them on the screen for you. And then it pays attention. Because if you give it a new object and you make some new UI components, it says, are those different than the last ones? And then it does the narrowest surgical incision it can to change the screen so that it now looks like what you just asked for without having to blow everything away. And at the end of the day, if you were going to describe React, that is supposed to be the secret sauce, is that you don't bother worrying about what changed. You tell me what it should look like now. I'll figure out how to change it in the fastest way I can to be effective for you. So at the end of the day, we're talking about producing new values that we keep putting out there, which happens to marry really, really nicely with the idea of a framework that's all about projecting brand new values and then it figuring out what needs to be updated. So there's a certain marriage and there's a certain reason why these two concepts can work really nicely together. It doesn't have to, but there's a reason it can. And I do think that there's some parity between them that can work really well. And when you get to hooks, all these things, React hooks are just an extension of a functional concept. All of these things are just drawn from functional concepts. Just like Reducer was, just like anything else, a hook is basically a function that gets called every time and either returns a memoized value from the previous invocation or it does something new if it realizes something changed. It's effectively a form of memoization coupled with a function and a couple other little things we could get into. But that's what it's about. So anyway, you don't have to like it. You don't have to love it. You never have to use it. But I do think it's an interesting way to look at the world and to question at least why doing it one way is better than the other, or why every doc you'll generally see has a case statement in it or a switch statement. Because go to the React page and go read about useReducer, and you'll see a giant switch statement. And I just have to ask you, does that really feel like the way we should be writing anything? Just anything, literally anything. That there is a way to write code that way. But I'll throw it back to you, Ron. I know you do more low-level stuff in the way you look at it. You would definitely register, some type of index of a bunch of function pointers and jump to them if you needed to apply something. It's how you would do it at a low-level language. Just happens to be it's a little higher level here, but it's the same sort of things, that we've always done, and they are the same sort of concepts. Nothing I just showed you, by the way, is new at all. It's all derived from Lisp and Scheme and shit that happened in 1970s that everyone who's mostly doing this stuff today has no idea about and believed got invented last week. But when you have the privilege of being around too long, you get to see the cycles that happen over and over and over again as we reinvent the same things and find that the next Kool-Aid is in fact last week's dirty water.
So I hear you, Mike, but especially with React being, even way back when, if you remember Andre Stoltz and his Cycle.js, which came out very shortly after, and he's the guy who was I think he did the RX Marbles diagrams and stuff. Yep. Really smart guy, and he came out and everyone had agreed that React was kind of leading everyone towards this functional paradigm with JavaScript. And he came out with Cycle.js and was like, yeah, just fucking jump on over, man. You're already doing React. Just go full functional. And it never happened. And it never happens. We see it all the time. I have the same gripe with the push for purely functional concepts in JavaScript as I do for classes in JavaScript. Like I have the exact same disdain because, actually maybe it's not even a disdain, but my question to you would be, because I just want to have a religious argument.
Yeah, go on
it. If functional JavaScript is, the way to go, why has it not taken a hold? Why are we not all over RxJS and writing our code this way? Why do, when most developers look at functional programming, we identify it immediately by the fact, it's a common complaint, right? All the little variable names, single letters, and whether you're chaining or like wrapping a whole bunch of things. Because your pipe thing is awesome, but in reality, it's going to be a pipe inside a pipe with a function inside a function inside a function with some little extra thing that needs to be added, and you need documentation on that extra fucking thing.
So look, I'll give you a couple answers. First of all, I disagree that it hasn't taken off, because in a certain area it has. But hold on, just stick with me.
I'm with you.
A couple of quick answers. First of all, you know what's generally taught in pretty much every school and college? They teach Java and really imperative, terrible, crappy, ass backward, shitty, the worst you can possibly imagine Java, written by people who probably never should write code, which is the reason they're teaching it. Okay? So, first off, there may be a small problem with the education.
Let me know how you really feel.
I was being nice.
This is a safe place.
Right? But look, everybody comes out learning the same basic stuff out of colleges, out of their educational programs, and there's a certain bias towards it. Here's the interesting thing. It depends on where and when, because in college, I was sort of in, and there's all different terms for things like AI and machine learning and stuff now, but they were different then. So I did learn Lisp and Scheme in college. So to me, this doesn't seem weird at all. But to somebody who went through all of college learning only Java, of course this looks weird. To somebody who learned it, that was there. But then you have to go back and say, is it weird? Or is it just because this is what you've always seen, right? And there's two different questions there, and I think they're fair. Also, and I will be very clear about this one, and perhaps my slight disdain for the state of the software community, it's really easy to issue imperative statements. And by the way, functional is not the opposite of object-oriented. Functional is the opposite of imperative, okay? Object-oriented can be layered in between. They're not necessarily opposite of each other. They're orthogonal, okay? It's really easy to say, I want to write code that says do this, do this, do this, do this. And it seems really straightforward and do that. It doesn't scale necessarily very well, okay? It invariably, there's nobody on this call who hasn't debugged somebody else's race condition in code. Race conditions in code happen because we have different people issuing edicts, which are imperative things saying, do this now, with no regard to the state of the system at that moment, okay? So we have this paradigm that is created by a programming style because it was easier to learn. So the real question then becomes, was it ultimately better for anyone because it was easier to learn to begin with? Perhaps. It's okay for something to be harder to learn if it produces a better product in the end. I'm going to take an example from, and not everybody likes this dude, so stick with me. His name is Martin Odersky. Martin Odersky is the person behind Scala and some languages before that. Also a really smart dude who wrote one of the first Java JREs and compilers, okay? One of the reasons is that Scala is not imperative, so it is functional, although it does have object-oriented concepts. Okay, so just another point that they're not opposite. They did some cool profiling of a Java application when they were designing it. And they figured out that better than 50 to 60% of all the time in a complex Java system was spent trying to make sure one piece of code didn't step on the toes of another piece of code. Because with all these statements, we needed to have locks and database locks and memory locks and thread locks and locks and locks and locks and locks to make sure we didn't step on each other. And at the end of the time, in these complex systems, they're like, wow, 55, 60% of the time is spent basically making sure I don't shit on your state and you don't shit on mine. So they said, what if we just copied stuff and did it in a functional way? Turned out that copying all of the memory that was in use ended up being only half as expensive as it was to actually make sure that we don't break this each other's stuff. So Scala was in fact developed because of the fact that it was easier to say, let's build these things. Yeah,
say one thing. So I started off arguing against functional programming.
Yeah.
And you're trying to sell it, but you just added to your pitch also immutable, which we don't have in JavaScript. It doesn't exist. Stop trying to make it immutable. It's not a thing. We don't have immutable data in JavaScript. Stop it.
Wait, there's a difference.
And Scala, maybe Lisp, Haskell, these are all academic languages, and there's a reason they're academic languages for big brains like yours.
Okay, I'm taking bets on Joe. Okay, anybody want to take a bet on Michael?
Look, I would take a bet on
There are no winners.
First of all, Scala is not academic. It's what they ported Twitter to when it could no longer do them or fail with.
I say Scala, I meant Lisp.
Yeah, okay. So
Lisp, Haskell, all that, like, really neat.
Right.
Here's my solution to the Euler problem. It's one line that nobody can read, and it works.
All right. So here's the deal, right? When we look at immutability, it comes down to this question. So I'm going to address that one first. Immutability is the idea that you don't change something. Enforcing immutability is different than immutability. Saying I don't change something is something that you can do in JavaScript, in C, in assembly, in any language you want to. Preventing you, like if you get the gun and you point it at your foot, there are certain languages that say, like, no, stop, please move the gun away from your foot. JavaScript is not one of them. Okay? JavaScript will let you go ahead and do it. JavaScript may even give you a larger weapon, if you would like, before you finish aiming at your foot.
I was just going to say, C gives you a Gatling gun.
Yeah, exactly. I mean, and C, you can just iterate over function pointers in memory and just destroy it all at once, right? Like, and that's the beauty of it.
You don't just crash your application, you bring the whole system down.
You know, I mean, I may have one time needed to optimize something, so I just replaced the handler for the timer with a C function that I knew would run on the interrupt. I mean, it worked great. And you can do those things in C. Maybe not advisable, but you can do them. The gist of this is, though, that immutability as a concept is different than enforcing immutability. I agree with you. JavaScript doesn't enforce immutability. I will also tell you I have lots and lots of code that doesn't mutate. However, I don't care. Because some of my code mutates under the hood because that's
point. Okay. That's a good argument. Well, I don't care.
There are times that mutation makes sense, right?
You may have just won.
Let's say that I'm in a big function that's going to do a bunch of hairy stuff. I don't have fine. I can mutate things internally, but the outside world can still see it as immutable. They don't have.
I don't think so. When I say immutability, and you were specifically talking about the benefits of immutability. Like, I know that talk about it turns out if we just it's fucking way more. I know all your Trojan horses, man. I know that.
Let's do it.
I do know that argument. But what you're talking about now, you're conflating idempotent functions with immutability. I agree. I don't know. We used to call it like byref, by value, whatever. But I understand that I shouldn't change the thing that was sent to me as a function, or when I write a function, that should be my goal, is to return a new thing. I'm fine with that. But immutability it's a bigger, it's like a whole other religion. There's a whole bunch of baggage that comes with it. If you want to say you should just write idempotent functions, that's totally acceptable, and you should use that, and that's a good rule.
Make my argument for me, buddy.
No, I didn't.
It's simple.
No, I didn't, because immutability is a whole other weird fucking thing where we have to do all sorts of weird shit.
Just hold on, out of curiosity, if you write a function and I give you a value and you don't change what I gave you, then that seems like you'd have to give me something new. That's the word I was looking for. And if every time I gave you something, you gave me something new, and your function.
Right.
No, I'm not done yet. I'm taking my time to make this point.
I also have to do a bunch of work to fucking make sure I unchange shit. So, immutability. Once you introduce immutability, it's not just you sent me 1 and 2, and I need to return you 3. It's you sent me a giant fucking object, and I need to do a whole bunch of work to make sure that I don't fucking change anything in that giant. That's what immutability leads to. Is that nonsense you see in actual Redux reducers, where you've got to figure out how the fuck do I change the property on the third element in this array with a bunch of squiggly lines and dots and shit, when you could just use immer.
So your point, though, was that you were in support of the idea that if I gave you something, you wouldn't change it.
I'm in
your original statement.
Idempotent functions.
So if I give you something, do you think you should change it?
If you give me something, if I'm a function.
Uh-huh. And by the way, remember, there are all languages that used to classify the difference between procedures and functions.
To be prepared for me to change it.
And that's why we don't work together. No. So look, I just think it's really quite simple. I'm not saying craziness, or I don't care if arrays are technically immutable. There are all kinds of cool things you can do if you can make those assumptions, but I'm not even worried about those right now. I'm just saying I think the idea of a function, which originally literally was that a function returns something. And if you look at, and they were academic, but languages like Pascal, they separated procedures and functions. The idea of something that returns something, the idea of something that does something, right? They were different.
Sure.
And
functions and subroutine.
Yeah, but the gist of this is that I'm just saying, like, if we just agreed on the contract that, hey, I'm going to give you something, but I don't expect you to change it. So if you need to give me back something new, give me back something new, right? I'll write you a letter. You don't cross out the words you didn't like in it so that I can get back a letter that means what you want. You just write me a new one. Otherwise, you look like a serial killer, dude. So
that's actually an interesting metaphor.
Don't be a serial killer.
Joe just cuts the letters out and glues them on a new piece.
Right. Just give me back a new letter. So
I give you back a better letter. You know,
went a different kind of way.
Right. So, all right. So that said, and yes, Trojan horse to it, but it's the same thing that we talked about a long time ago. We also know that one of the big things that happens right now is that we, even in JavaScript, are looking at threads. We're looking at different ways of doing things, all of which require, by the way, copying things because we can't really manage the complexity of pointing to the same things. So now we could make a decision that, cool, in all of our JavaScript over here, we'll mutate stuff. But when we go to use a thread, now we have to worry about copies. Or I suppose we could just do it the right way to begin with. That would be another possibility. But I like your idea too. So, look, I'm not even nearly this invested in it, but I do think there's some interesting parts to it. And at the end of the day, code that works is what matters. But I do find on the whole that people tend to write themselves into corners and paint themselves into corners all the time. And I have found that while it does take longer sometimes to write functional stuff, and it does sometimes take longer to reason about it, I have found that people paint themselves into less corners. And so for me, that has been an advantage over time. And that's really all on it. I mean, I think there are honestly so many different ways you can solve this. And I don't really think that there is like a superior one, but I do think there are some cool advantages to this technique. That's all.
No, I personally really enjoyed your presentation. Like I said, I think it makes me more interested in using useReducer in this way at a component level, not out like beyond that. I don't think. You mentioned something about, I don't know what language or whatever you were talking about locks, and I had to double check, and it's Rust that has this whole ownership concept. Where you like this piece of code owns it and has to like release it before another piece of code. I forget all the terminology in it, but they've like, you know, that exists again.
It got so bad that Intel at one point was trying to make a processor that could automatically infer what piece of code had access to memory so that they could make it faster for other pieces of code not to access that same piece of memory or to make them wait. But like in a database, for anyone who's worked in that, it's very similar, but it's more obvious there. We have deadlocks. Somebody's updating something, somebody else is waiting on something. Sometimes we get to the point where two people need to update something, right? The same thing happens in code. And when we're in any form of scenario, we have semaphores, we have locks, or we have what I like to refer to as the poor man's semaphore, which is a flag that somebody sets that says, I'm busy updating this, don't screw with it. But
checked it out. I've checked out this file.
There you go, right? But at the end of the day, those are all because, and this is a place that you could argue would be a bad idea, right? Like instead of me modifying the source code you gave me, I'll just give you a new one every time. I would argue that would be a bad idea. So there are times that I think mutation's a good thing. But that is it, right? Is that anytime that two people could potentially modify something, you either have to ensure they can't make conflicting modifications, or you have to have a strategy to incorporate those conflicting modifications. And that is the crux of it. And if we're doing something millions of times a second, that overhead becomes really intense at some point. And so a lot of this comes down to how do we potentially eliminate it? And again, and I know this is the Trojan horse, but it's true, as we go to more processors, as we go to more distributed things, as we go to virtual machines all over the place, guess what? They don't have shared memory. They are going to have to pass things between them, and they're going to return new versions of things. So if we write code that perhaps has all those assumptions, guess how easy it is to make it run on multiple machines instead of one? Guess how easy it is to make it work on multiple processors or multiple cores instead of one? When you have something that assumes I can modify, reach into your object and twiddle your bits anytime I feel like it, then it becomes a little more difficult when your bits are located at a different location than I thought they were.
Joe, embrace the Jamstack, man. Embrace the Jamstack. They're all dysfunction. Just
shut the fuck up with your Jamstack.
Across the cloud.
Has that not died yet? The Jamstack, isn't that already over? Is that still going on?
Yeah, it's going. Yeah,
it's another year or two, I think.
Lambda. So look. There's lots of ways to see the world.
I understand the resistance to jumping into functional. Like you started your presentation, and you kind of hit on this as, with a function that does A plus B, and you bastardize it into something that wasn't recognizable. And you just basically said, "But trust me, downstream, it's going to really help you out." And the average person would go, "You took some code that made perfect sense and turned it into something that is." Indistinguishable from gibberish, essentially. So until you get over that hurdle, people are going to resist it, I would think.
It's the same thing, though. I'm going to go use an assembly metaphor for a moment, right? It's the same problem people have, is that in assembly, what do? We push something on a register and we jump to someplace new. So what do you have to understand? You have to understand what was on the register before you got to the new location. And a very common thing would be that we have two entry points that push something onto a register that jump to different points secondarily, and they use what was on the register. That's nothing different than that higher order function I wrote, where you effectively retain something and then jump to a new point who's going to use the original value plus some new one. And so I get it. It is complex, but that's also the same thing. And the same argument, people are like, I can't understand assembly because it's impossible. Well, okay, it could be for some people. I think it is possible, though.
Yeah, in assembly, you assume there's some infrastructure for doing call processing, calling subroutines. You got to invent that. You don't get that for free. You jump somewhere, it doesn't necessarily come back to you.
You've got that Stack all the time to work with.
In assembly.
Most people have no idea what a Stack Overflow is, by the way. That also cracks me up. All right.
I think
it's a website. What are you talking about?
In the functional
talking to you, Mark.
thing you were showing there, Mike, it was really, I think people have the most problem with knowing what the intermediate states are after each step.
Yep.
I think that's where most people run into trouble is they see this big long chain of functions, and you could see it in jQuery, for example, when you're ... Right. You're like, well, the 12th function call in this chain, what's the input and what do I expect the output to be? And so them, and it kind of becomes the Perl example, right? Is you can write Perl, but you can never debug it, right? You get the stream, you make it all work, and you're like, yes. But then you go back to it and you're like, oh, it does take some mental effort to...
Always easier to write code than it is to read it.
So I think that's a dilemma for a lot. And you see that in RxJS too, where you get enough pipes of modifiers of things in there. You're like, I was good a few steps in, but then I'm not sure why I'm flattening here. Why do I need to flatten now?
I know you'll totally be surprised to know that I really like RX too.
I'm shocked.
I love the idea.
Delete this recording.
I'm going to have to beat you up at another time on your pipe analogy, though. Comparing it to the concept of pipe under the Unix Linux world is a bit of a stretch.
It's not actually. If you actually look at the implementation of pipe in Linux Unix, it doesn't look all that different.
Except that they're streams, and each one is a separate process, and they run in different time slots. And pipe number one starts immediately, even though our pipe number 2 starts immediately, even before pipe 1 finishes. So I assume you don't have that in this version.
So in that version I wrote, obviously not in a couple lines, but that's the cool thing, is that technically there is absolutely no reason you can't do that here either. With threads and everything else, we can do very similar things. They can run in independent processes. They can run in lots of different ways. So in fact, there's a version, it didn't go anywhere, but there's a version in Intel released of JavaScript that was briefly short-lived, and in a couple other languages like R that are fairly functional right now, where people have basically taken operators like map and reduce and automatically put them into parallel processing, where each one of the steps is running by itself and then is recombined. So there's all kinds of cool stuff you can do.
Yeah, in other languages, I mean, in Python, you can manage processes and threads and stuff. You said there is a version of JavaScript that supports threads?
Yeah, well, we can do very limited threading right now in very specific ways. There's worker threads. There was an entire, and we'll see, things go and come back, and then sometimes they come back in new shapes and forms. But there were several prototype versions of JavaScript that did a bunch of cool stuff like that, and then they became hard to optimize and get working on mobile devices. So they got shelved because mobile devices were harder to work with, and then so we'll see what happens in the future. And here's the thing: I like JavaScript because it has a lot of reach. I don't think JavaScript is in any way the world's ultimate language. Yeah, scary, huh? I like it though.
It pays the bills right now. It pays the bills very well,
for
and
me
it has.
to write, and I like it because I can be very functional in it very quickly. I can get a lot done. Doesn't mean that I think it's without fault.
How does all this functional stuff play with TypeScript? Because that's also a thing that has a lot of weird religion behind it. Do you TypeScript, Mike?
I'm TypeScript curious. Yeah. So look, I actually do a little bit. I've never completely adopted TypeScript, and it's not that I don't think there is value, but I don't feel like it's all the time quite as fluid, and it could just be my learning curve. Sometimes I feel like it gets in my way when I'm trying to do things. Flip side is, one thing that's nice about TypeScript versus traditionally typed languages is that TypeScript, there are classes and there are other things, but there's also just types, okay, structural types, meaning that you can identify something as unions of a structural type, kind of, going back to union size and union looks. And that can be quite useful in how we build things and can work quite well with functional stuff. So I do think there is some promise to TypeScript. I will be very clear that comparatively, I have very little experience. The stuff I've done, I've had some success and some failure. I actually spent last weekend adding types into a project that I finally lost track of. It was this massive parser I wrote, and I'm like, all right, I need to put something in here so that I can come back into this at some point and understand. Unfortunately, I thought it was going to take me an afternoon, and 3 days later, I was still trying to get all the types right. So I may be coming off some fresh wounds from that. But I think there's value there. I think that I think it also is another thing, though, that has a pretty big learning curve to get it right. That's all.
So now you could write your parser with a single useReduce?
It is effectively, actually, if you really want to, it's a reducer across an array of combinations of predicates that determine whether or not this is the right token, and a function to apply if it is.
And with that,
if you want to do a whole session on parsers sometime, we can do that.
Oh, I would be all over that. I've done my share of compiler building.
Cool. We can do that.
Well, I'll let you know when we find a compiler meetup, and the two of you can go at that time.
You guys don't want to hear about the time I worked on a C compiler written in Fortran?
Sure, go for it.
Mark does.
Oh, look, I can mute people. Oh, look at that. Oh, what a shame.
Ron, if you and I just keep trading back and forth, I could talk about my just-in-time compiler for a HCA.
I could mute Mike as well, but that might mean less pizza, so...
All good. Anyway, this was fun.
You are muted, Ron. Ron, I actually muted you. I did actually mute you. It was just a test.
Bastard. Oh, that's a dog, sorry.
Oh, you're unmuted right when you said that.
Yeah, look at that. Does that work?
We'll bleep that out.
4 times.
Oh, really? But we won't bleep out what you say. Really?
I bleep out my things when it needs to be bleeped out.
You can just bleep out everything I said after the presentation if you
I
wanted
think
to.
you went 3 whole minutes.
Replace all my questions. Like, Mike, why don't you love functional programming and immutability and TypeScript?
Mike, why don't you love people?
That was actually very well done.
Anyway, thank you, Mike. It was a very cool presentation. You are such a good speaker. I mean, even if it's difficult to follow along, you are still a very engaging speaker.
I recognize that, Mark, you had a problem following along, but I am curious because I thought it was a really good step-by-step walkthrough, very well-named functions and taking the time to explain them. I thought it was pretty easy to follow for something that did get non-trivial at some point.
My problem is not being able to follow along. My problem is being able to read the code later, because 10 seconds later I can't remember what you said. Right? That doesn't mean it's not easy to follow.
It was built in blackjack, right? You kind of knew it was coming, and you know he stopped before like double down and splitting and things of that nature. Like and then your mind's going like, oh, I can see how to do double down splitting. That one would be a little trickier. But
actually, I have a demo that goes that far, but I'm long-winded, so we didn't get that far.
So the real lesson is never play blackjack on a computer.
Yeah. Or at least with a computer.
Go to Vegas and find an actual table. There you go. Great talk.
Anyway, thank you, Mike.
Appreciate it.
Yeah, it was great. Thanks for having me. It's always enjoyable just to kind of show up and show some stuff. And we'll figure out how to do a compiler talk, but not tell Mark what it's going to be ahead of time.
Yeah. Don't worry about it.
Well, you
Mark,
succeeded
you let
this
me do a
time.
V8 internals talk one time, remember? Like, I mean, honestly, nothing's going to get worse than that.
Is that a threat or a promise?
I mean, once we got to talk about hidden classes and code gen and V8, really everything else after that's, we're cruising. We're cool.
Cool.
Our next session is on June 24th. We don't currently have a speaker for everyone who's left on the call. If you want to talk, let me know. I'm just going to start handing out topics.
Well, Ernesto's not here, and we haven't seen Todd in forever. So, I think you should start there.
I think I talked to Todd not too long ago, maybe like a month ago. He's around.
You should do one on immutable structures, Joe.
Jeez.
I try not to give talks, but I someday I should. I should just do. I mean, not that I haven't given talks, but I should just do a talk on why I hate TypeScript, immutability, functional programming.
I think you actually have the same opinions.
Yeah.
Kids on your lawn, people who litter.
Right. You kids, get off my lawn.
Joe shouting at the sky.
Right. Next up, Joe, you kids get off my lawn, let alone with his talk on TypeScript.
I hate all the Rails. All the things that are keeping me safe suck. All the things that are making me do the right things suck.
It's all about the gun and the larger caliber.
All bad.
I'm going to do on TypeScript. It makes me think of this T-shirt I saw that says, I didn't spend all this time clawing my way to the top of the food chain to be a vegetarian. That's what TypeScript feels like to me.
I love TypeScript, and everyone should. Everyone should hate TypeScript.
I agree.
I think you and I agree, though, that TypeScript at some point is pretty much JavaScript and TypeScript don't have a separate future. Eventually, we're going to have JavaScript with optional types.
Optional types, and you know what? When optional types show up, you're an asshole if you don't use them. This has happened before in other languages, and you have to turn it on, and if you're not turning it on, you're a jerk. But it'll be more reasonable, and it won't turn perfectly valid JavaScript into TypeScript errors, which is really my, other than like we've seen CoffeeScript, like, I don't know, check it out. And if there's two libraries and they both do the same thing and one's written in JavaScript and one's written in CoffeeScript, you tell me which one you're going to use and which one's still being supported and maintained. It's always going to be JavaScript. Somebody somewhere has said, always bet on JavaScript, and TypeScript is not JavaScript. And it's certainly not a fucking superset of JavaScript.
Did they add real integers to JavaScript yet?
Do you mean like big?
They're real as long as you don't want to make them too big or too small.
Right.
They're real.
Well,
Hey, we have big numbers now.
The types that we don't use, but they're there. Big ints.
Yeah.
And,
Big int's there now. Big int's actually kind of cool.
Big ints?
Yep. Like real 64-bit, real 64-bit ints that are actually represented and don't do weird type conversion things when you try to use them in big space.
And so forever we've had typed arrays. Like, you don't ever need to use them. Like, I've run into it with like doing BLE stuff, like playing with web Bluetooth. All of a sudden, I'm like, I guess I got to learn this bullshit. So there's JavaScript is a very complete language that until recently was growing at a very steady pace. But
it still is. Like, to be honest,
I think it's growing in adoption. I think I think we could probably do a little D3 example or like feed some stuff into a nice chart, prove that progress is slowing right now.
Yeah, I think they're focusing on different things, right? Because remember, like, coming out of ES5 and, well, even before that, there was the big break when like ActionScript and C# were the bleeding edges of innovation for ECMAScript stuff. It fed back in and they started doing this. And so they got up to the point where like the ES6 stuff, which I think is the place where I actually started wanting to use JavaScript again, is when we got some of those things. And so now it's going to be like language tweaks. But yeah, I think JavaScript's probably not going to go through revolutionary change anytime soon. It'll be evolutionary.
We're not seeing the big jumps that that I think actually like what was it, 6 to 5, which is now Babel, brought us. But I will say we are starting to see a lot of traction in CSS. They now have like a CSS Stage System. And that's actually pretty exciting because I've always hated CSS. Until,
I would say if you want to like really evoke my hate, let's do a talk on CSS. Because
I mean, outside of everything, it's always positioning, right? Like fonts and colors and widths and paddings and margins and box models. That shit's all fine. It's always positioning. And Flex got us really far. And now Grid has pretty much like there's a learning curve there. But there's too much, just like with Flex, like there's I don't know, there's like 13 different properties you can set. At the end of the day, you need like 3 of them, and they've all been reduced to like really simple classes with libraries like tachyons. CSS Grid is the same thing. Like right now, it's like so many fucking things to learn, but the reality is you need like 4 of those things.
I think the CSS is always. CSS is interesting because there's always this weird relationship between and sizing and positioning of like children and parent and what counts in what case. And it's really actually hard to, without like understanding it at a very deep level, it's hard to get a sense of it. A couple people on my team literally went and read the spec because that's the only reason they actually understand how and why some of the things work at this point. And that's one of the things that I've always found tricky. And it's a joke. It's a running joke in my office because if you need me to write the shit I just wrote, I'm on it. If I need to center something, I call somebody else because it's just not going to be me. It's not going to happen.
Right, but that's been solved now. Flex solved that. And CSS Grid.
I believe you that somebody knows how to solve that. I'm saying it's not me.
I don't really know a ton about Post CSS, but they do have one plugin called Post CSS env preset, maybe. And all it does is let you turn on stage levels. So there's a cssdb.com. You can go there. You can see what's at what stage now, like just like we have JavaScript proposals or CSS proposals. And you can just say I want all of stage 1 or all of stage 0, or I want these features or whatever. And there's some really Just I don't know why anyone uses like Sass or Sass or less or any of those any longer, because you get all the basic things you want. We have variables now. I mean, those just work in the browser. And like one thing, you know, you can turn on nesting. That is something that is going to come to CSS, which is going to be like very welcome by pretty much everybody. Like I don't think anyone's going to have a problem with the ability to scope shit finally.
Yeah. Oh, speaking of which, two things on that. First of all, I just want to say that people that actually do know CSS well are amazing. I'm not one of them. But I talked about this before. You and I both like web components. One of these days, not the next one, but one of these days, I'll do a talk on hybrids.js. I still think you'd actually kind of dig it if we get into it at some point.
We talked about that, right?
Yeah.
I'm guessing that I brought up, I know a guy who swears by stencil.
Yeah. And we talked about it once, and I was like, oh, we should do a talk on that. And then when you asked me a couple weeks ago about doing a talk, I totally forgot that we had said we should do our next talk on that. So now I'm putting it back on the list of things we can forget.
Okay. So June 24th. All right. Yeah, again, if anyone wants to talk, June 24th is our next date. I'm sure we have a date for July as well, or thereafter. If you want to give a talk and you haven't given a talk in a little while, you're welcome to. I think we're good. I think we actually lost our meeting organizer guy.
There he is. He's back.
He just wants us to leave, and he's trying to give us every hint he can. Yeah, I don't blame him. I'm long-winded. I get it.
No, thank you very much, Mike.
Thanks, Mike.
Hey, it was great. Thanks, everybody. I really enjoyed
Thank
talking
you,
to all of
Mike.
you. So it's nice to catch up. So everyone have a great night. All right.
All of you in person soon.
Thank you.